key concept in algebra is the concept of quadratic equations, and I want to introduce you to that right now. Okay, so we say an equation is quadratic if it can be written in this form: ax squared plus bx plus c equals 0, and the key element here is that I have a degree 2. I have an x squared or a y squared, something squared. That lets me know I'm dealing with a quadratic equation. In particular, these are quadratic equations with one variable, only x, or only one variable. And there are several techniques to solve these things, and we'll go over different techniques. The first one you encounter, though, is factoring. And the way factoring works, it relies on this property. If I can take two things, multiply them together, and get 0, then I know that, in this case, a and b, I know that either a is 0 or b is 0. And we call this the zero product property. If we didn't have this, then factoring wouldn't work. And so the idea is, I know how to solve linear equations. Is there a way that I can take a quadratic equation and break it up into the product of two linear equations set equal to 0? If that's the case, or two linear expressions set equal to 0, if that's the case, then one of those has to be 0, and then I can solve my equation. So I'm going to show you some examples on how to do that, and hopefully it makes sense. So I have these three examples of quadratic equations, and I want to solve them all by factoring. And if you remember what I said, the strategy is to be able to factor them to turn these quadratics into two linear expressions set equal to 0. So for example, in the first one, I have to have 0 on one side or factoring doesn't work. Okay, so first of all, I'm going to move the 8 over. So I have y squared minus 6y plus 8 equals 0. From there now, I'm able to try to factor. And the way I want to think about this is I want to think of two things that multiply to give me 8 and add to give me negative 6. So I'm thinking, how about negative 4 and negative 2? Those multiply to give me positive 8, and they add to give me negative 6. And okay, so there I have it. Now I've turned my quadratic expression into two linear expressions set equal to 0. So from there I get the two linear equations, y minus 4 equals 0, and I get y minus 2 equals 0. And remember, the reason this works is because of the zero product property. So from the first one then I get y equals 4, and from the second one I get y equals 2. And if you want to write them together, 2 and 4. There are my solutions. Okay, and again, this only works because of the zero product property. Two things multiply to give me 0, so you have to have 0 on one side for this to work. Okay, now for question B, we have 3x squared minus 9x equals 0. Alright, so I already have 0 on one side, so now I just need to try to factor it. And what I'm going to do here, the first strategy you should always try is to factor greatest common factor. And here I can do that, and I can take out of everything, I can take out a 3x. And if I do that, in my first term, I'm left with an x, and the second term, I'm left with a minus 3 equals 0. So now I have written my quadratic as two linear expressions multiplied to give me 0. So that means either 3x equals 0, which would imply divide both sides by 3, x is 0, or x minus 3 is 0, so I add the 3 over, I get x equals 3. So there are my solutions, 0 and 3. Okay, now for the last one, it's a similar deal, just looks a little uglier. First, I need to get a 0, right? So I'm going to have x squared. I'm going to subtract 5x over 3 from both sides, and minus 8/3 equals 0. Okay, I still don't like this exactly because I don't want the fractions. So what I can do here is multiply both sides of my equation by 3. And in doing so, when I distribute the 3, I'll have 3x squared minus, so when I distribute 3 here, that becomes minus 5x, the 3's cancel, and then lastly, minus 8, and 3 times 0 is 0. Okay, so there I've done it. Now I just need to be able to factor this, and the way I can factor this is through a method called grouping. So what I'm going to do here is I'm going to take my 3 and negative 8 and multiply them together. So that becomes negative 24. Now I need to think of two things that multiply to give me negative 24 and add to give me negative 5. Okay, now this won't always work, but this happens to be negative 8 and 3, being my two numbers that I need. Now what I'll do is replace the 5x with that term. So I'll have 3x squared, let's say plus 3x, I can do it either way though, minus 8x minus 8 equals 0. And notice that this term here, the 3x minus 8x, is actually just negative 5x. I've just separated it in a very clever way, because now I can do a grouping technique where I group my first two terms together and I group my second two terms together. And out of the first group now I can factor out greatest common factor. I can take out a 3x and I'm left with an x plus 1. Out of my second group I can take out a negative 8 and I'm left with an x plus 1. And now I have two terms that have a common factor of x plus 1. So I take out the x plus 1. Out of my first group now I'm left with a 3x. Out of the second group I'm left with a negative 8. And there I have it. I have factored it. So now I get the equations x plus 1 equals 0 and 3x minus 8 equals 0. So for the first one I end up with x equals negative 1. For the second one, let's see, I get 3x equals 8. So that would mean 8x is 8 over 3. Okay, so then as a solution, I'd probably write negative 1 and 8/3. So x equals those, and there it is. Okay, so there are three examples of how to solve quadratic equations by factoring. I hope this makes sense. If you need more practice with factoring, I have a set of videos that go over those, and I encourage you to look at them and hopefully get some insight. Factoring is the basic principle of most algebra questions, and so it's very important to understand. If you have any questions, please let me know. I'd be glad to help, and thank you for watching.